Alright, Technical Manual 5650, Technical Manual, Central Boiler Plans, approved for public release, distribution, unlimited, Headquarters Department, Army, 1989. Alright, 163, Section 6. Auxiliary equipment, 236 feet water heaters. Closed feed water heaters of the tube shell type that you have to preheat the feed water going into the deaters. Hot water boilers are well for the deaerating heat. These closed the feed water heaters can be make use of the turbine exhaust system or water heat generated of the boiler plant to improve overall plant efficiency. Deaerator heaters are surge tanks. Condensating return tanks are discussed in Chapter 4. Figure 2104 illustrates the closed tube shell heat exchange using feed water heater. 237 pump injector. Selection and replacement of the pump requires the consideration capacity, pressure requirements, the type of the temperature of the fluid to be handled, the type of the pump to be the best suit for the job, requirements, performance characteristics, widely even among the pumps in the same type capacity. Pumps can also be classified in 4 groups: central figure pumps, reciprocating pump, piston pumps, rotary pumps, and positive displacement pumps. Jet pumps and injectors. Characteristics for these groups are discussed later. Installation. Selection of the pump, particularly with the job involved with any consideration, but once the pump is selected, selection performance depends upon the details of installation. These particularly true with the pump must be lifted fluid. When the fluid is heated, the greater the care must be exercised. The design and installation of the suction line of the plasma discharge. The strainer is required to prevent the foreign object from entering the clogging of the pumping piping. The maximum suction lift, the maximum suction lift, minimum suction height, depth, the great extent upon the temperature of the water, the distance of the pump above the sea level is noted in Table 2.7. The following rules shall be observed when installing a suction line pump. Disregarding any of the following rules may lead to unsatisfactory operation, complete failure. The line may be tight. A leakage discharge line may be annoying, but a leak in the suction line may lead to incorporating in operation of the pump. All right. Figure 2103, wet approach venturi scrubber. Gas in, gas out, water sludge out, venturi scrubber. Alright, your tube shell heat exchange. 2104. Alright, 2. Keep the suction lip vertical distance from the pump of the water supply as small as possible. Keep the suction line as short as possible. Keep the number of the fittings and such as the shells, teeth, and reducers valve to the minimum. To reduce the loss caused by the pipe friction, high velocity, keep the diameter of the suction line as large as practical. To prevent formation of the air pockets, maintain the properly slope of the horizontal section pipe, the slope of the line away from the pump of the suction lift toward the pump of the suction head. Reference figure 2105A6. Do not use the fittings to permit the formation of air pockets. Reference figure 2105B. Note any chamber that occasionally use the suction line of the pump to smooth out the pressure fluctuation surges. They must be carefully designed and installed to ensure proper operation. 7. To keep the line and group full with water when the pump is idle, install the foot pedal within the end of the suction line. The foot valve is a special type of the check valve made for the purpose. The very little force is required to operate it, and strainer is usually incorporated. A foot valve has no value when pumping is located between the source of the water supply. Properly guarded, all gears, belt shafts, and other moving parts are exposed to the hazardous content provided the drains and pump base. Table 2.7. Permissible maximum suction lift for the minimum suction head feet in various temperatures. 60 to 260 to 120, 210 degrees Fahrenheit, and increments of 20 until you get to 210. At sea level, 2,000 feet above, 6,000 feet above, 10,000 feet above. Alright, central figure pumps. Central figure pumps are rotating the impeller with the given velocity pressure for the fluid. The type of the pump is widely used for the boiler feed with the condensate. The pump action figure 206 illustrates the horizontal split case type of the central figure pump. Central figure pumps are very available to many configurations, including single, double section, single, and double volatile, multiple stage vertical. Although these pumps look different, they all have basically the same components operating similarly. They are compact with a simple construction, discharge, and uniform rate of flow pressure containing no valve. The piston operating with a high speed can handle the dirty water. They have 2 major disadvantages: comparatively low efficiency and ability to discharge air and vapor. However, their advantages more offset the lower efficiency. The inability to discharge any of the discharged air can be overcome by the proper installation operation practices. Construction: the pump should be shown in Figure 2.106. It's if the rotating element called the impeller with the casing of the shaft, the parts of the youth, installing the pump against the leakage. The impeller consists of two discs separated number of the varies with which for the passenger with the water and the connected with the hub. The impeller may be cast iron, bronze, steel, or other alloys depending upon the fluid to be handled. The diameter depends on the operating speed. The difference between the suction discharge pump pressure. The pressure difference is usually called by the pump head, measured in feet, and then propeller may either single or double at suction. One shown is the double suction type in which water enters the bowl side. B. The casing split and horizontal center line contains the inlet and outlet passage. Inlet and outlet connections usually on the bottom half of the casing permit disassembly with repair of the pump without disturbing the pipe connections. Pump alignment and the casing guides with the water with the inlet connection to the impeller with the impeller with the discharge connection. The casing, although usually made of cast iron, can be made of other materials necessary to handle the special fluids. The shaft supports the drives impeller to determine the support of the bearings. Babbitt type of the bearings also use the pump as shown in Figure 2.106, though many pumps are also use ball bearings. D. And the impeller is held firmly with a sheath sleeves, which help seal against the leakage into the pump. The sleeves are held placed by two nuts, one which for the right hand thread, with the other hand left hand thread. Packing is sometimes provided between the nuts of the sleeve to ensure the tight seal of the stuffing of the box provided with the shaft passes through the casing. Stuffing box are filled with the packing held in place with the packing glands. A brass bronze lantern ring is often inserted between the two adjacent rings of the packing to provide a channel with the sealing water. The sealing water lubricates cools from the packing. The shaft sleeve helps to seal against the leakage into the pump. It may be supplied directly from the pump and show that from the outside surface source. The casing of the renewable rings reduce leakage from the discharge inlet side of the impeller. Renewable wear rings occasionally installed with the impeller 2 operation. When the pump is operated with impeller rotates high speed, drawing water into the center near the shaft. The resultant central figure force imparts energy to the water, which is forced outward. Alright, 20115A. Pump, good design. Pump, poor design. Suction line insulation, good design. Poor design. Air pocket, flow. Central fusion pump, starting on the right. Suction discharge passages have volume shape. Pump and case horizontally. Suction discharge openings lower half in the casing. Starting at double section closed type bronze impeller, moving clockwise. Fiber pack bearing. With single holes inspection, oil rings, and oil replenishing oil, coupling in for the drive lantern spacers, renewable bronze wearing rings, forming labyrinth seals, casing a support, forged steel shaft, protected bronze sleeves, oil reserve adjustable throttle thrust collar, large horizontal split ring oil type bearings limit lined with Babbitt, and deep water seal stuffing boxes. Alright, this occurs with the partial vacuum of the produced with the inlet draws the additional water. The casing must transfer the velocity of the water, leaving the impeller into pressure with the minimum loss. This is done with the pump shown with the making the case of the form with the spiral called the volatile. Gradually increase the cross-sectional area from its beginning with the pump. Discharge of the pump shown is called in a single-stage pump, but because of the water passes through in one propeller, multiple-stage pumps are also used, but necessary to operate with the against higher heads, and a multiple-stage pump with the water travel through the successive impeller stages that have been reached the desired. B. The output central figure can be controlled with the regulating of the pump, provided with the control recirculation line, throttling the discharge, the recycling line, bypass consists of the valve line between the pump discharge suction outlet pump and decrease with the opening of the valve, the grease separating water through the pump through throttle discharging, increasing the pressure of the pump outlet, causing some of the fluid to stop and remain in the pump casing. Any of the control methods can be manual, automatic. Central figure pumps must be coupled with a check valve and the discharge side to prevent backflow of the water one of the pump one pump is inoperative. Central figure pumps are designed to deliver given a quantity of fluid against the specified discharge pressure head. Every central figure pump has a maximum shutoff head, and above which is unable to deliver any fluid. The fact should be taken in consideration when increasing delivery pressure for the contemplated shutoff head can be sometimes increased substitution large impeller, although large motors are also required. Reciprocating piston pump. The direct action steam driven duplex pump is widely used because of the low initial cost and low maintenance, simple operation, positive action. Simplex pumps are rarely used because of the wide fluctuation of fluid pressure pumped in the discharge. A horizontal duplex position piston pump is shown in Figure 2107. The type of the pump consists of a two-single cylinder pumps mounted on side to side. The piston routed one pump that actually operates the steam valve, and the other with the system bell cranks the rocker arm links. The piston moves alternately so that the resultant discharge of the water essentially continues the steam and emits with the full stroke, not expensively resulting in the high steam consumption amount of the water handled. Each cylinder has two ports on each end. One of which emits the steam with other discharge. The minimized required the valve travel the bed leaves sufficient bearing surface between the steam ports and maximum main exhaust port to prevent steam leakage from one to another. The steam, which is trapped in the cylinder when the exhaust stroke of the near completion, provides the cushioning of the preventing the piston, the striking the cylinder heads. Some of the pumps also have the small handled operated valves on the side of the steam chest to regulate the amount of cushioning of the controlling the escape of the steam from the cylinder. Maximum cushioning is desired for the pump operating with a high speed obtained without closing the handle. 3. The valve of the duplex pump do not overlap the edge of the port of the valve this bit mid-position. The valves are all held with the seat and the pressure differential actuating on the two sides of the valve. Figure 210H shows the relative position, working position when the pump of the valve is mid-position. The illustration indicates the valve must not be fastened rigidly to the stem. There is loss of motion between the valve and the stem. This loss of motion provided with the force pump to take a full stroke. Otherwise, it would make only about a quarter stroke. The typical operation of the pump also due to this loss of motion. One piston has completed its stroke. It pauses and goes into reverse only after the second piston has reached the end of the stroke and moved its valve. One piston is always positioned to move, and so that the pump goes into operation as soon as the steam valve is open. Alright, rotary positive displacement pumps. Rotary positive displacement pumps use gear screws and sliding vanes to move more volume fluid from the pump. Rotary positive displacement pumps are most commonly used for the Army boiler plants to the pump of fuel oil. Very close tolerances are maintained between the pump intervals, minimize the slippage fluid. Slippage in the positive displacement pump may be less than a fifth 0.5% or slippage of 50% of the most common central finger pump. These pumps can also operate with a high efficiency pressure. Rotary positive displacement should be equipped with a relief valve to protect against the overpressurization, while the central finger pumps may be controlled with the throttle flow. The rotary positive displacement pumps are controlled by the reciprocating of the portion of the pump fluid back into the tank of the pump suction. E. Jet pumps and injector. Injector of the jet pump used to feed water into the boiler. Whether there is thermal efficiency justifies its use. Most of the heat in the form of the steam used to operate with the pump is returned to the boiler with the water. The injector is conventionally cheap, and the compact efficiency has no more parts. The delivery of the warm water into the boiler without preheating. There is no exhaust and dispose of it. It cannot be used with the proper hot water that can handle the maximum water heat with about 440 degrees Fahrenheit. Excessive preheating of the feed water passed through the injector also often causes impurity to drop into the tube, scaling of such so heavily that the injectors fail to function. Alright, 207, the reciprocating piston pump. Your steam inlet, side valve, exhaust steam ports, piston, steam cylinder, drain plugs, loss of motion valve, rod, packaging nut, rocker arms, piston rod, crossing head, packaging box, water discharge valve, suction valves, water cylinder, suction plunger nuts, and flower plate. So it's reciprocating piston. That's steam engine. 2108. Two methods of providing lost motion. Lost motion, steam port, steam port, exhaust cavity. Lost motion, lap, steam port, exhaust port, steam port. Two methods of providing lost motion. 2109, rotary screw pump, external bearing, hard face, screw face, hard balance, mechanical seal, external timing gear, variable pitch, double suction. 2109B, rotary gear pump, thrust bearing, maintenance seal, rotary casing, integral relief. The essential part of the injector are the steam tube combined with the delivery tube, the necessary case for the guide with the water and to and from these tube. The reference figure 2.110, the shape of the steam tube designed the shape of the ventry increases the velocity of the steam passing through the tube. As a result, the high velocity air partially evacuated the inlet line, causing the water to rise to the contact steam and enter the combined tool. The steam is condensed and part of the considerable velocity of the water. The condensing steam reduces the volume, thus maintains the vacuum. The combined food tube further increases the velocity of the moving the mass water, enabling it to cross another delivery tube. The water velocity opening the check valve of the water into the boiler against the boiler pressure and overflow that is provided with the remove the water when the injector is started. No water should be appeared to overflow. The injector is operating with the properly. Injectors can be hard standing automatic single double tube. An automatic injector will resume its flow after the eruption with any of the portion of the operator. The injector operates satisfactorily under the constant load and pressure, but becomes unreliable operating with the fluctuating pressure. Due to this fact, to the low temperature limitation, injectors are rarely used with modern insulation. Injector failures are rarely used on modern installations. Injector failures are most often cause excessive suction and lift in the hot water clogged strainer on suction line fluctuating pressures. Boiler feed pump. The boiler feed pump is probably the single most important auxiliary in the boiler pump. It must be operated continuously while the boiler is in operation. The rate of the discharge is equal to the rating of the boiler. The code requires the boiler to have two methods of feeding water to ensure the adequate supply is available to all times. Reciprocating jet pumps can be used with the proper central figure, most commonly used with the modern stationary practice. Central figure pumps have an advantage of small size, high speed, low chance of boiler water containing with contamination with oil and continuous steady flow. Reciprocating pump application. There are steam cylinders. Reciprocating pump ranges from 2 to 3 minutes, 3 times the water piston plunger to allow the friction loss to permit the pump operation at the reduced steam pressure. The boiler feed pump is required to pump against the total head of range at 1.5 to 1.5 times the boiler pressure. Reciprocating pumps must be sized to provide the desired water discharge capacity with the pumping operation approximately one half the maximum stroke rate. This allows the pump to wear and provides the marginal emergency so the low water rupture tube. Reciprocating pumps in the direct action duplex type are sometimes used in small capacity moderated pressure. They consume the approximately 5% of the steam produced with the boiler, so that the exhaust utilized with the heat of the feed water within the net to consume with the pump can be less than 1%. Alright, 2. Central figure pump application. Central figure pump boiler feed application must be sized to develop enough head capacity to feed the boiler under all conditions. Central figure pumps must be driven with a steam turbine, variable or constant speed motor. The method used to control the output depends upon primarily on the type of the drive used. The central figure pump used with the hot water must provide with the adequate flow of the water at all times. Central figure pump quickly at the steam bound within a stop. The pumping around under certain conditions may be damaged if permitted to operate under these conditions any length of time. G. Condensating pumps. The reciprocating positive displacement rotary central figure pumps with the surface head heating system, generally with the automatic flow operated with the central figure pump condensated drains to a return tank or reservoir. The flow operates the motor switch with the start and stop of the central figure pump. And one arrangement of the motor is one tip of the tank of the pump is at the bottom. Another arrangement of the pump, the bottom motor is mounted on the side below the return tank. Vacuum pump. Reciprocating jet and positive displacement rotary pump must be with the vacuum surface. The central figure pump can be used to supply the water to the jet, which actually means the vacuum reciprocating pump arranged to remove both condensating the air at the same time is called the vacuum pump. This common arrangement is used with the small condensing turbines, engines, small clearance in the water end of the characterized pump. The use of the surface of the pump, which removes only air to the dome of the dry vacuum pump. The vacuum pump with the recurrent heating system must be handled with both air and water. One method of doing this pump with the two impellers mounted within the shaft. One impeller handles the water and the other air. The condensating flow of the receiver enters the pump. Automatic control actuated by the water level pressure in the receiver, which is below the atmosphere. Start and stop the pump as required. This arrangement can maintain about a vacuum of 10 to 18 inches of mercury in the system when reasonable, free of leaks. 238. Forced draft fans. Forced draft fans are applied to push the combustion air through the burner into the furnace. It is induced. The draft fans not supplied with the forced draft fans must also push both products and combustion through the boiler to the sack. Figure 210 shows the steam injector to the boiler. Goes steam inlet around the force stem of the main steam valve, lifting rod, overflow rod, regulating valve, lifting tube, sub, steam nozzle, feed, water suction line, overflow, auxiliary overflow, forcing tube, forcing steam nozzle, main overflow valve, check valve to the boiler. All right, both centrifugal axial fans used with the centrifugal units being more common. The centrifugal units include the following blade designs: radial forward, cleared, forward curved, backward incline, airfoil, backward incline, airflow, backward incline fans are most commonly used for the forced draft of the fans because they are high efficiency, stable operation, no overloading. Horsepower characteristics: forced draft fans are required to operate without a load of approximately 25 to 100% of the capacity, accomplished primarily by the use of the damper. The three types of dampers are used: inlet dampers, parallel blade outlet dampers, outpost blade outlet damper. The figure 211 illustrates the forced draft equipped with an inlet vane. Figure 212 illustrates the typical blade type parallel blade outlet damper. Inlet vane, G vane dampers are airflow through the fan and pre-spinning the entire entering air. Each position is inlet vane damper with the effective creates a new fan horsepower curve that's shown in figure 211.3. The result improved the control range horsepower savings over outlet damper application, which control the creating the static pressure of the fan. This increased static pressure reduces the flow of the cause the operating point to move back on up the fan course. Reference figure 2114. Opposed blade outlet dampers provide with a greater control range for the parallel blade outlet dampers, which operate at the best 70 to 100% capacity range. 239. Induced draft fans. Induced draft fans are usually exhaust the product with a combination with the boiler, maintain balanced draft with the condition for the furnace, improve with the boiler operation, provide energy to move the flue gas with the velocity needed with the good heat transfer. The induced draft fans are subjected to the move more severe surface condition with the force with the draft fans because they most handling the large volume of the gas with a high temperature containing the ash particles. Physical characteristics of the ID fans must therefore differ from those of the forced draft fans. Airfoil blades are recommended for the ID fan surface. Backward incline fans are acceptable non-abrasive gas surfaces when radial or radial type blades or forward curved or backward incline fans are recommended for the abrasive surface. The higher temperature for the gas handled by the ID fan sometimes makes it necessary to use water-cooled bearings to prevent overheating and inlet damper and controlled variable speed drives as used to control and induce the draft fan capacity. 240. Stacks and fuels, stack flues and ducts. Stacks and chimneys are necessary to shove the product with combustion sufficiently high elevation to prevent nuisance due to the low-flying smoke, soot, and the ash. With a certain amount of the draft is required to conduct the flue gas through the furnace of the boiler's tubes and economize their air heat and dust collectors. The stack can help reduce the part of the draft, the heat of the stack necessary to meet the first requirement, often enough to also produce the draft necessary to meet the second equipment. The amount of the draft available to the stacking depends on the height of the diameter of the stack, the amount of flue gas flowing through it, the vent elevation above the sea level, and the difference between the temperature of the outside air with the average temperature for the gas inside the stack. Excessive slack temperature or undesirable because of the represent heat loss and efficiency of the reduction. Stack construction. Stacks are built with steel plate masonry, reinforced concrete. Cage ladders should be installed. All stack guys should be kept clear of the walkways, roadways, subject to the highest contacts with properly guarded. Stacks are provided with a means of cleaning acid and water from the base of this means, depending mainly on the side of the track. Alright, 1. Steel. The advantage of the steel stacks of masonry or reinforced concrete are reduced with the construction line, lower the weight, and smaller wine surface lower in initial costs. Major disadvantage of higher maintenance costs and shorter life. The steel stacks may either be self-supporting guided or single wall, double wall construction line, or unlined guided stacks usually are used in a smaller insulation. The type of the stack can be supported from by the boiler, smoke box, the building structure, and the separate foundation with the two sets with the floor guide wheel wires, each for the usually hold stack erect. Steel stacks over 72 inches of diameter, normally self-supporting. They are typically lined with the refractory insulation to protect the metal with the corrosive action. Flue gases to improve the performance. Stack of the minimizing cooling flue gases. Self-supporting stack is usually mounted on the foundation and or building structure framework. Stubs and venture stacks are typically on the steel construction, usually extend no more than 20 feet above the boiler. When the stacks are used, they contribute little of the draft requirements, which must be then supplied entirely forced by the induced draft fans. Brick. The modern brick chimney, built in special radial brick and block, is very satisfactory. Its major disadvantage being its higher cost. The type of the stack, normally lined with the fire brick, is about 1/5 of its height and must be protected from lightning. Flues and ducts. Flues are used to interconnect boilers, outlets, economizers, air heaters, stacks, and ducts are used to interconnect forced draft fans and air heaters, wind box, combustion, air plenums. Flue ducts are usually made of steel. Expansion joints are provided too. Allow the expansion of the contraction. All flues duct with the carried heat air gas should be installed with minimized radiation loss. Outside insulation is preferred for the maintainable flues ducts and designed with a short possible free flow from sharp bends and abrupt changes in cross-sectional area of adequate cross-sectional area with minimized draft loss and design flow rates. Alright, this one shows 211 shows your forced draft fan with an inlet damper. Your airflow going in through the impeller rotary, through the bearings and shaft on the impeller rotary, inlet valve vane through the airflow driving motor. 21112 typical outlet fan dampers. They're bush like shutters. They hang over your like ducts. Figure 21113 fan curves for different inlet valve positions, airflow, CFMs, and suctal pressure, and a brake horsepower. 21114 fan curve with the fan without damper, the airflow CFMs, and the brake horsepower per hour over the static pressure. 241 steam turbine. The reciprocating steam engine will need for with its need for oil lubrication resulting in contaminated steam has been replaced with the steam engine electric motors. Steam turbines driven from the power plant auxiliary are generally economically only for the exhaust steam can be used for the feed water overheating is the application of the steam turbine using rotary rotating wheel while the buckets and blades uniformly spaced around the conformance transform the heat energy steam. The mechanical engine works with steam expanding through a nozzle directed against the buckets cause the wheel turn various type of the steam turbines, different construction arrangement of the nozzle, steam passage bucket. The steam turbine is essential with a high-speed machine is best used with direct connection electric generators, pump fans, and with direct connection low-speed machine. The common known non-condensed turbine operates with efficiency at only about 20%. Only special circumstances and necessity of oil-free exhaust system can justify the use of small turbine for any purpose other than standby emergency. Figure 115 shows a single-stage impulse non-condensed steam turbine. 242 electrical motors. Electrical motors can be grouped into three general classes based on the power source. Their classes are direct current, single phase alternate current, three phase alternate current. Three-phase motors are available. The squirrel cage is a synchronized wound motor. The squirrel cage motor has been dominated because of the low cost, the high reliability, the high efficiency over the wide load range, high starting torque. It is estimated that 90% of all electrical motor energy is consumed in three-phase squirrel motors. Not all squirrel cage motors perform equally. However, they will need to replace and install new motors. Exist modern higher efficiency, higher power factor designs should be considered economically analyzed. Usually justify slightly higher initial cost, high efficiency motors. 243 electrical equipment. Electrical equipment used with essential planes include the motor starters, the control circuit breakers, switchgear, transformers, fire brake, protection, lighting, conduit, and wiring. Operation of these devices involve the voltage, which is dangerous to life. Operating personnel must observe the safety regulations found in Army Manual TM 5682. Additional information on electrical equipment can be found in the Army Manual 568G, 56883, and 56884, 56887. 244 variable speed drives. Electrical mechanical fluid variable speed drives. Available electrical drives include multiple speed motors, variable frequency controls, variable voltage control. The development of solid state components has also been designed for the variable frequency controls, which can be operated with high efficiency over the wide load range. Mechanically variable speed drives include belts, adjustable pulleys, gear, reducer gear, transmissions, fluid drives. Fluid drives include a variety of hydraulic couplings. 245 air compressor. Three basic air compressors are available: the reciprocating, rotary, and central figure. Air compressors may be further classified in oil-free or lubricated. Air compressors are used in the Army installation comparatively small units. Final discharge pressure approximately 100 psi. They are typically a rotary screw or single stage reciprocating design. The two types discussed in TM 58104 may be referenced in additional information compressed air system. Compressor type. The reciprocating compressor is the piston type with the positive displacement. Machine air volumes can range of approximately 60,000 CFMs. The two-stage compressors are frequently used because they require less power to compress the given quantity of the air due to single-stage machines. Cylinders, intercoolers, two-stage machines may be cooled either in air, water. The needs shielding of the baffling structure, noise attenuation. It requires investigation when reciprocating compressors are required. Your rotary screw. Rotary screw compressors are also classified positive displacement machine operated with the passing of the inlet air through the inlet valve, then compressing it through the action of the two helical screws rotating against one another. Air volumes can be ranged from the high of 3,000 CFMs, but are typically at 150 CFMs. Package units are readily available in size up to 500 CFMs, where they incorporate the necessary filters, coalescers, coolers, and signal factories designed assembled. The liquid sealed rotary screw type units are available upon up about 300 CFMs to provide oil-free air of the type of the compressor recommended for the food. For processing healthcare, recommended for food processing healthcare facilities, not often used. In boiler plants, it's most often common to provide oil-free air to boiler plants made with the filter separated the combination of one of the compressors types discussed above. Alright, this shows a single-stage impulse, non-condensed turbine. Your bearing case has an inner and outer slingers keeping the dirt out. Liner bearings snapping into the without scraping. Separate packaging casing. They can replace carbon rings without lifting into sealing the main case. Rotary locating bearing elements, shimming and adjustment. Sealed directing active mechanical speed. The governor. True center line, dynamically balanced rotor, water jacket bearing housing that can be drained without insulation valves, separate force actuated positive closing over speed jump. That's a single stage impulse non-condensing turbine. B. The capacity air compressor. Total air requirements should be based upon not upon the total individual maximum requirements upon the sum of the average consumption of air operated with devices. The compressor capacity should be based upon the calculation procedure examined in TM 58104. After coolers and process compressing air, approximately 80% of the energy delivered in the electrical motor becomes heat energy stored with the compressed air with the air elevated at temperature. After coolers required to cool the air to the more usual temperature. After coolers, the heat exchange with the side to cool the air with the dew point so as to allow the oil vapor to condense. The moisture separator is attached to remove the condensed vapor. The aftercooler is normally cool out with the water, but is what may use the air in the heat exchanger medium. B. The air dryers should be some compressed for the application of moisture removal. Addition will provide the aftercooler. Such application with the boiler plant includes the pneumatic tool operation, pneumatical driver to dampen the volume of the instrumental air. For these applications, supplemental drivers require the three basic characteristics exist: refrigeration dryers, regenerative dryers, the liquidation dryers. Regeneration dryers are type that usually made in the boiler point plants discussed here, and information on other types that may be obtained the manufacturer from TM 58104. Refrigerator regenerative dryers are further broken down into three types: heatless and descendant, heat regenerative, and low temperature regenerative. The heatless descent dryer. The heat descent regeneration passes with the quantity of the dried purge air through the off-stream bed. No external heat is applied. The type that should be selected with the field adjustment purge control so that the purge rate, therefore pressure dew point, can be adjusted accommodating seasonal variations in ambient temperatures, but they reduce operation costs. Heatless dryers are capable of providing minimum of 150 degrees Fahrenheit pressure dew point. Maintenance costs are low since there is only a few moving parts, with adequate pre-filtering. Move the oil descendant replacement requirements for the minimal. Heat regenerative dryers. Heat regenerative dryers utilize the heat with external source of electrical or steam in conjunction with the purge of the regenerative off steam. The reducing amount of the purge required with the regeneration of heat regenerative dryer operating costs may outweigh the maintenance cost and downtime. Low temperature regenerative heat pump dryers usually thermal energy from the inlet air of the off-stream tower regeneration. No electrical heaters or steams are used. The type of the dryer provides economical refrigerated drying, low pressure dew point capability. Descendant drying, refrigerating cooling is used to remove most of the incoming moisture to cool the on-stream tower of the high absorption efficiency. The system saves energy, and since the heat energy is removed from the inlet system stream, is required recycle the refrigerator, compressor, and discharge the off-stream tower with the regeneration. Stable pressure dew points down to minus 100 degrees Fahrenheit realized with this type. Are your the air receiver. The air receiver steel pressure vessels constructed in accordance with the ASME boiler pressure vessel code section 8, which are sized to dampen the pulsation entering the compressor discharge lines of serve the reservoir suddenly unusual heavy demands of excessive compressor capacity prevent the frequently loading unloading the compressor and to allow the moisture oil vapor carrier from the aftercooler precipitate. The recommendation from receiver side of the mounting name of the EM58104 drainage valves and piping and safety valves pressure gauges must be installed in accordance with the code. 246. Steam traps. Steam traps are used to discharge condensate air, but not steam from pipeline or heat exchanger. No single type of the trap is ideal for every situation. The four major steam traps are thermostatic float, thermostatic disc, thermodynamic, and entered bucket. These discussed below orifice impulse traps are produced to operate in discharging steam continuously, therefore not recommended. This waste as well as waste of steam, the effective damage traps representing the energy loss is not acceptable. Proper maintenance of the steam trap discussed in paragraph 5.4. Thermostatic steam trap. The thermostatic steam trap can be further subdivided in balanced pressure with the thermostatic trap of the liquid expansion type traps, biomedical traps. All three subtypes working sense the difference between the steam temperature, cooling, condensated temperature, utilizing spanning below the bimetal strip operating the valve head. The usually discharge condensating below the steam pressure temperature, therefore requiring collecting a leg before the trap allows for some condensating, cooling. The balanced pressure thermostatic trap is illustrated in figure 2.11.6. The thermostatic traps are typically used for low-medium pressure applications such as steam radiators, submerged heating coils, or steam tracing lines. Float and thermostatic steam traps. Float and thermostatic steam traps, figure 2.117, are recommended for use. The figure 2.116 thermostatic steam trap, condensation steam. Figure 2.117 float thermostatic steam trap, steam and condensation. Whenever possible, the valve seat is always underwater, preventing any steam loss. The discharge continues to modulate for the condensing rate. The unaffected change with the inlet pressure, the separate thermostatic air pressure, and then independently purges air, keeping the startup of the discharge of the pair with the main valve seat without affecting the operation. Typical application for the float thermostatic trap of the air unit to the hot water heater of the heat exchange converter. This thermatic steam trap. Disc thermatic straps are widely used due to the size of small size of the wide pressure range on one moving part of the resistance of water hammer the corrosion because of the operating on each of the model depends on the manufacturer's heat and the design. This design required results may be widely. Many of the prone or binding or startup operating below steam temperature, causing water line will have relatively short life due to the soft seat. The disc materials containing the bleed slot, which cover the rapid cycling steam loss. Properly designed disc and thermodynamic traps can overrange from the problems. Although effective and efficient operation, they are typically used with the high pressure superheated steam drip legs and steam tracing lines and unit heaters. D. Inverted bucket steam traps. Inverted bucket traps, figure 2119, have been in existence for the many years. They are low in initial cost and helps keep them properly all through every application superior result they obtain with any other type of trap. They consume a small amount of steam. Operation can blow fully open if they lose the primary due to the oversizing rapidly due to inlet pressure. The discharge is intermediate, not continuous. The typical applications include high pressure indoor steam main driven submerged heating coils. Or your piping system. Piping and tubing systems are used with the central boiler plant to transport a wide variety of fluids, including among the water, steam, oil, natural gas, compressed air. The following section is intended to brief overview of some of the components considered, which are piping and tubing systems. The word piping is manually generally by assumed to mean the piping tube. Strictly speaking, however, there is a difference between piping and tubing that is discussed and briefly in subparagraph C. Design codes. Designing of the boiler plant piping generally govern the design codes industry standards. The American Society of Mechanical Engineers Boiler Pressure Vessel Code Section 1 was discussed in paragraph 2.9 as also applied for the boiler's accessory, also covering a certain portion of the piping around the boiler, but much of the balance in the piping in the boiler plant is covered by a power piping code. American National Society National Standards Institute B31.1. Additional design codes, their applicability given in Table 2A. The design code is general specific material that may be used for their scope. How the piping inside the thickness must be determined. How the pipe must be supported with the type of the fittings, joints, and accessories may be used. Other provisions, although the codes are written primarily for the pipeline designer and engineer, the general knowledge of the provision is useful as the operator well. Materials. Piping materials generally specified with the design code are under the system built with the most common piping material in the boiling plant is steel. Steel piping strung relatively easily worked and available in a wide variety of size, most application of pressure, temperature, fluid, and other piping material is the arc. The use of the are used specific applications, including copper, stainless steel, cast iron, plastic, and some common application with various materials included in Table 2.9. Size is standard specification size for the primary difference between the piping and the tube. The pipe size specified in the nominal pipe size or NPS and schedule of the tube size for given outside the diameter of the wall thickness. Pipe sizing. Nominal pipe size. The nominal pipe size refers to the diameter of the pipe. The nominal pipe size ranges from 1/8 of an inch up to 30 inches in standard increments. Outside of the diameter given the nominal pipe size is always the same. The inside diameter varies depending upon the schedule. Schedule refers to wall thickness and the generally listed with the Schedule 40 and Schedule 80 and Schedule 160, etc. The earlier practice, which is still used for the occasion, would refer to the schedule designated in standards of STD, extra strong XS, double extra strong XXS. Dimension tolerance corresponding with the nominal size schedule is established by the American National Standards Institute standards. There is no easy way other than referring to a chart to determine the actual dimension of the given nominal pipe size. For instance, a 1-inch nominal pipe size schedule, the 80 pipes has outside diameter of 1.3 and a half, 1.315 inches of wall thickness of 0.179 inch, inside diameter of 0.957 of an inch. Or your tubing size. The tubing size is specified by the outside the diameter wall thickness, allowing the theoretical available to almost any diameter ranging from the 400 few hundred of any of the inch pipe up to several feet. And this tubing in the boiler plant is limited to the size of about 1/8 of an inch and 1 inch. Tubing in the common side of the boiler plant is generally either copper, stainless steel, major exemption for the rule within the boiler itself. The boiler manufacturers generally using tube rather than pipe. For most part, the use of the carbon alloy steel. Determining the proper size piping system must be sized, regulated to a number of the criteria, including the type of the quantity, fluid, and transport pressure, and temperature conditions. Allow the velocity and pressure in these calculations to become quite sophisticated and outside of the scope of the manual. The pertinent design code should be consulted for guidance. This shows the disc thermodynamic steam trap. The disc steam condenser. Inverted bucket steam trap. Steam condensation, and you can see it's got like a bucket with a valve on it that lets out the condensation. Figure 2.8 piping codes and standard for the boilers. American Society and American National Standard Institute. Power boilers, welding qualifications, power piping, iron, steel pipe, pipe flanges, fittings, bolts and nuts. American Society testing materials, and NEMA, steam turbines, National Fire Protection Agents Association, sprinkler system, automatic spray system. American Welding Society qualification for the welding procedures and welders, piping and piping and tubing. Typical piping material application: carbon steel, low alloy steel, stainless steel, cast iron, copper, plastic. Typical application: typical joints. Fitting joints. Pipe and tubing joined with a variety of ways, including threading and welding, flange, variety mechanical coupling, type of the soldering, for copper, brass, solvent welding, for plastic. All of these methods are common. The type of the use for the particular application used to specify the design code for the steel pipe and the high pressure system used, such as the steam boil feed water common use welded joints as do the system of the large, approximately 2 to 3 inches. The small diameter system of the steel pipe may be threaded or socketed. Welded flanges are often when the piping may be disassembled periodically. For instance, the performance maintenance values other components fitting in the flanges available with the material thickness for the corresponding with the pressure and temperature requirements of the piping system. Pipe supports for the piping system requires sophisticated design qualifications outside scope of the manual. Some of the general criteria must be considered in making these calculations discussed below. Allowable stress. The design code for each of the application generally provided with allowable stress levels. Each of the material level must be determined. Experience that have the adequate safety margin. They must be adhered with the allowed stress given the material, the function, temperature, and decrease of the high temperature. Expansion of flexibility. As temperature of the pipe changes, the pipe must move due to the expansion of the contraction. Provisions must be made in the pipe supporting the system, accommodating the movement, providing the pipe flexibility with the bends, expansion loops, expansion joint requirement about the expansion must be determined. Calculating stress in the pipe and ensuring the lines have less than all allowable stress. 3. Anchor and support. Almost an infinitely variety of the anchors and hanger supports may be seen in center boulder plants. A variety of the hanger type has been standardized by Manufacturer Standards Society (MSS). Some of the most illustrated figures of 120 custom design support structure feet, steel shaped sharp standard hardware. Also common valves are available with a wide variety of type materials, pressure tape, which are arranged with corresponding to the type to the system in which they are used for their purpose in the system. Some of the type of the specialized valves are discussed everywhere elsewhere in the manual. Gauge cocks, paragraph 210. Safety valves, paragraph 213. Manual boiler outlet valves, paragraph 214. Blow-off valves, paragraph 215. Control valves, paragraph 225. Several additional common types discussed below. Special applications being discussed. Manufacturer representatives to ensure the correct body of the internal material set, design, packaging, discussing material, and other details. One function. The valve can serve many different functions of the piping system. Broad categories valve function include the isolation on-off, throttling, control, backflow, prevention, pressure relief, and regulation. 2. The gate valve. The gate valve is a simple design operation commonly used with the boiler plants. Gate valve to achieve the minimum pressure drop. It is important that the employer where the valve is operated with the wide opening of the valve closed if the position is up to operated and incorporated. Gate valves are not designed for throttling operation under prolonged, usually partially open position. Damage to the seat and disc may occur. A solid wedge type of the gate valve is illustrated in Figure 211 or 2.121. Globe valve. The globe valve is used primarily for the throttling position to create definite pressure for the globe. The globe valves are available with common partial globe seat contact with the speed needed for type. Numerous variations, some such as top guide, post guide, angled, wide pattern, yet fluted, cage gate guided. Because of their inherent ability to exhibit repeatable flow curves, their most common types, common use type of the valves are control valve. The application globe valves can be used in on-off surfaces with drop and pressure drop in the fully open position, not primary importance. Normally, globe valves installed with the flow under the disc, but in certain cases where the is desired to have a line pressure system maintain steady closure flow may be directed over the disc and motor air actuated valve. The flow direction is very important. Size actuated standard size single port globe valve is illustrated in Figure 122. Plug valve. The plug valve is a refinement of the earliest known valve, the spigot. Basically a 90-degree rotation, open and closed position, tampered interval valve. The downward thrust of the plunger tapper exerts the compression load of the sidewall, inserting the continuous circumferential sealing surface of the light of like the gate is used for the primary on and off surface of the plug. Valve is added benefit with the bubble type sealing, thus making it ideal for the gaseous surface. In addition, because of the other large unobstructed flow passages of the plug valve is ideally suited for fluffy surfaces. A typical plug valve is illustrated in Figure 2.130.23. 5. Butterfly valves have been used in the industry for decades, performing well-defined tasks in which they distinct advantages other than valve types. Some of the butterfly designs can be dependable, bubble-tight shut-off, other than ideal suited for throttling control applications having an equal percentage of flow characteristics. Butterflies are quickly open. The high efficiency can be operated manually, automatically, and can be used handling a variety of the media, including liquids, solids, slurries, glass, vapors. Figure 124 illustrates typical butterfly valve. All right, check valves are. Or your hanger rod with the roller. You have the beam, the welded seam attachment, hex nut type, the continuous welded rod, the turnbuckle, typical insulation piping, saddle, roller. These are standard hanger type of the piping systems. You have a spring hanger pipe, the pipe clamp, welded eye rod, hex nut, spring, clevis pin, beam. Hanging 221. It shows a solid wedge disc gate valve, gland packing nut bonnet stem body solid disc, single port glow valve, packaging gland packaging bonnet disc body flow, and then we return to the check valves. Check valves are designed for the piping system where the protection against this reversal fluid flow is desired. During operation, liquid gas pressure will remove the disc off the valve seat, allow the fluid flow with the valve minimum pressure of the drop, and the fluid flow sees the reverse direction. The reverse fluid flow design of the disc assembly will form the disc against the seat, preventing the fluid backflow. This weight seat configuration internal spring resistance provided with all contributed to the ease in which the disc opens, closes the leak tight when in closed position. Check valves can be obtained with a wide variety of styles and fit specific applications. Two or more common types: swing check, spring-loaded lift check. Also illustrated in Figure 215. Insulation. Insulation is used to reduce the heat loss, hot piping elimination, condension, reducing heat gain, and cold piping provided personal protection. Insulation type: the typical use in central boiler pipe systems include fiberglass, mineral wood, calcium silicate, jacketing vapor barriers usually incorporated over insulation to protect insulation material. Common jack materials include aluminum, fiberglass, cloth, various other fabrics. Our 2-1-23 is a non-lubricated plug valve flow plug steam seal steam insert. Your butterfly valve shows the lug and the butterfly itself. Your swing check valve, seat ring, flow, hinge, bonnet cap, body. Your wide type spring left check valve, spring, flow, check disc. Chapter 3, Operation.